Hey everyone, welcome to 2.5 Part 1, Implicit Differentiation. Now you say, what does that mean, Mr. Bartman? And I will tell you. So far we've covered equations in explicit form, and that's what you have seen throughout most of your math career so far. Things like y equals 3x, y equals 3 sine squared x plus 1. Anything where it's y equals is called explicit form. Now what we're looking for is what happens if it's implicit. Well, what does that really mean? Well, implicit seems like the opposite of explicit. So y isn't all by itself. Maybe it's x equals? No, not quite. Implicit form, I kind of said, I tried to link it to standard form of a line. Remember, like ax squared plus bx plus, ax plus by equals plus c equals 0. I could really say this again. Ax plus by plus c equals 0, or ax plus by equals c, something like that. Well, we can say that what happens if we have all the x's and y's on one side and we have either zeros or constants on the other. That is what we call implicit differentiation. That's what we call implicit functions. So we're going to do implicit differentiation on these guys. You say, well, why do we even care? What's so big about that? Well, if you had it the other way, solving, finding the derivative, doing something like that, it's tough to do when you have something like this, right? You have to solve for x, or you got to solve for y, you got to solve for one of your variables, and then you have to do all the work, right? I don't want to have to do 2 times the amount of work. I want to be able to do the differentiation, find the derivative. That's it. Easier. Rather than trying to rewrite this, especially when I got cubes and squares and y's and x's and all that kind of stuff. This is a much easier form, but there's a couple of things that we have to remember. So here's a first example. We're going to find the derivative with respect to x of x cubed. Because these x's are the same, we can find that no problem. That's what we've been doing up until this point. No problem. We can say that is really just going to be 3x squared. Right? No big deal. All right. Now we're going to say dx of y cubed, not the same. So what we have to do is we have to use the chain rule. All right? And the chain rule we can use because we're saying that y is going to be a function of x. That means we'd have like a y cubed equals x or something like that. We can differentiate y with respect to x because they're kind of part of the same thing. We have to make that assumption. And it's okay to make that assumption. You don't have to say that every time when you're solving these. We don't have to say y is a function of x. If they are both, like in this one, if we have both of them, you can kind of assume that's the case. We just have to include one extra little thing. Okay, so what we have to do is we're going to apply the chain rule, which means we're going to have 3y squared, right? Do the derivative of that, but we also have to, or of this whole thing, we also have to find the derivative of y, which is just going to be dy over dx. So it's going to be 3y squared dy dx, okay? And that's what we have to leave it as. That's as far down as we can go if we're trying to differentiate with respect to x. If we only have a y, we can say 3y squared dy dx. Okay, so now we're going to differentiate with respect to x. This one's okay, this one's not. So first I'm going to just differentiate the x. I know that's going to be 1. Done. I don't have to worry about putting anything else in because I am differentiating with respect to x. These match up. Now I've got the 3y, so I have to find the derivative of 3y, which is just 3, and then I'll also have to do dy over dx. Right? Got it? So far so good? Good. So that means I should have a plus there also. All right. So now let's do dx of x y squared. So now this is going to be kind of a tricky one, but using the chain rule. The first thing I'm going to do is find the derivative of the first part multiplied by this one, right? Derivative of the first one times the second. So that's just going to be 1, which is y squared, right? And then I'm going to keep going. So then I've got to do the other part, right? And so I have to add them. Remember, to add. I'm going to add them, and I have to find, this is going to be x times dx of y squared. Alright, so now what we really have to do is exactly what we did just up here, right? So I can find the derivative here, but don't forget the dy dx. Okay, so I'm going to leave this as the y squared plus the x, and now I'm going to have 2y, which is the derivative here, and I'm going to have to multiply that by dy over dx. And now I can clean that up a little bit. Let's just say this is y squared plus 2xy dy over dx. And there you go. So that is what we're trying to do with these. Does it get a little more complicated? Sure. but is it way better than trying to solve an equation for y just to go through and get it all? Well, let's see. Let's see if you actually do. Find dy dx given that y cubed plus y squared minus 5y minus x squared equals negative 4. So if you don't want to do this, you can pause it, try and figure out what y equals. Okay, so you've unpaused it, and you're still probably frustrated, and you probably don't have as much hair as I do because you ripped it all out because you're so angry, right? You don't want to do that. Let's just go through and find each one. So I'm just going to say we want to find d dx of y cubed plus d dx of y squared plus d dx, hopefully I'm not going to run out of room here, of negative 5y. Make sure you have that stuff. And then d plus d dx of negative x squared. Okay, so I'm going to do all of that on the left side. We also have to find the derivative of the other side, so I'm going to see if I can fit that in. D dx of negative 4. Got to say it higher if you're making it small. Sorry, I ran out of room. I thought I might make it. I couldn't. Dang it. Okay, so I'm going to find d dx of y cubed. So I know that's going to be 3y squared from what we did before, dy over dx, right? And then this one's going to be 2y dy over dx. And this one's going to be plus negative 5 dy over dx. And then this one is just going to be negative 2x. I don't have to do any dy's or dx's because I know that I can just find the derivative of negative x squared. And that's going to equal, the derivative of negative 4 is just 0. Okay, so now I can say I've got pluses in between them. Alright, I can do plus and negative if I want to, or just keep it as minus. Now, what I have next is these three guys all have a dy dx. So I'm just going to factor the dy dx out because I want to find dy dx. Okay, so if I do that, I'm just going to say dy over dx times everything that's left over there, which is 3y squared plus 2y minus 5. Close my parentheses in different colors, please. Alright. And then I have the minus 2x equals 0. So what I'm going to do is just kind of clean this up now, put this on the other side and divide by this stuff, and I should get dy over dx. I'll show you what I mean in case you don't understand when I said stuff. So I've got dy over dx, changes it back to blue, of 3y squared plus 2y minus 5, close my parentheses, equals 2x, and now divide by this, divide by that. I'm not going to write it out, so that way you can get dy over dx equals 2x over 3y squared plus 2y minus 5. And there is our answer. Notice how we still have x's and y's in here, so we can't just get rid of it. It's not gone, it's just it. Y. It's not like we just solved and said, okay, the y's magically disappeared and you have just some function of x. If we start with x's and y's on the same side, most likely what's going to happen is you're going to end up with x's and y's when you have dy dx. Alright? So, don't be afraid if you have something like that in here. Alright? And here is your next example problem. Determine the slope of the tangent line to the graph of x squared plus 4y squared equals 4 at the point square root of 2, negative 1 over the square root of 2. Alright, and before we actually do this, what I want to say is, could we solve this one for y? And what I'm going to do is I'm going to say, yes, I'll do it very quickly, and we're going to say that y equals plus and minus the square root of, we've got 4 minus x squared all over 4. So we could really even say that as y equals plus or minus, what is it? 1/2 4. Okay. Well, let's just leave it like that. Could you actually go through and find the derivative of all that? Well, sure. First you have the square root, and you have the top, then you have the bottom, and that becomes a quotient rule, and a square root, and a chain rule, and ugh, yuck. But if we can use implicit differentiation, watch what happens. Alright, so what I have to do is I've got this x squared, find the derivative of x squared. I know that's 2x, no problem. And then I have to find the derivative of 4y squared. I know that's going to be 8y. And then I have to do dy over dx. And then that's going to equal 0. Okay, now I want to solve for dy over dx, because that is really the slope, change in y, change in x, right? The derivative, the tangent line. That's what we're looking for. So get that 2x and divide by 8y, and I should get dy over dx is going to equal negative 2x over 8y. Cancel that out and reduce it down, and I can say that dy over dx is going to equal negative x over 4y. Yes? Man, that was easy. Alright, so now we just have to find the slope at this specific point, so put in the square root of 2 for x, put that in down here, and I should be able to get, let's just do it on the next page, negative square root of 2 all over, it's going to be what, 4 times 1, 4 times negative 1 over the square root of 2. Yes? Yes, so we can say dy over dx equals that. Alright, so if I kind of reduce this down, and I actually multiply by the reciprocal of this thing because I don't want to do that, so I can say negative square root of 2 times square root of 2 negative all over, really, it's going to be 4, because I multiply the top and bottom by square root of 2 over 1, square root of 2 over 1, and they're both negative. That means these are going to cancel out. The square root of 2 is times negative square root of 2, and then I get that to be a positive square root of 4, which is just 2 over 4, which is 1/2. A little bit of multiplying by fractions and things like that, but not too bad. Way easier than trying to find the quotient and all that kind of stuff. So here is your assignment coming up. Ready? I'm going to just make it appear. Watch. And there. Okay, there it is. dy dx of x squared plus y squared equals 0, and x plus y squared equals 1. One quick note that I want to say about this last one that I forgot to mention. I was going to, and I'll get that assignment back to you in just a second. Otherwise, you can always pause. This graph right here, do you remember what it is if we talked about from trig the different types of functions that we had with x's and y's? Remember your best friend? Remember him or her? This, since a and b are not the same, since x squareds and y squareds, the coefficients are not the same, that makes this an ellipse. We're really trying to find the tangent line to an ellipse at a certain spot. Okay, there you go. So again, here is your assignment, and best of luck to you.